Alright guys, we're live. Let's just share the link in the group. Now, if you're watching nobody live, you know what you need to do. Just skip ahead a couple minutes, maybe 3, 4, 5 minutes, so that you will catch up. Alright, I see it. Hey, we're looking like one person already get the live already. There's supposed to be a secret live. But let's just share this link some more. When you reach, say hello if you get through. Earlier today. Right, so I seen like people coming through. Right, Callista, Gaming Dude. Let's go get through this. Alright, so the homework was done relatively good, I find. The average mark was around 6.5. So which means, you know, like 7 out of 10 would be like a 1, which means everybody. And everybody need to be on a 7 at least for everything. So when we reach before the exam, we could push you up to even the higher level, right? Now there was a few 2s. And I think there was one 0. So if you know you cracked the 0, if you know it was you know you have to sort out yourself, right? There were a few 10s too, which was surprising because I made it really tricky to just really test if you knew what you knew stuff. Let's go through some of the 4 hardest questions, the 4 questions which people had problems with. This is one of them. Which of the following expressions is an example of scientific notation? So if you realize here, there were a lot of the answers here were close. Well, everybody knew it wasn't this one, but a lot of people put A as the correct answer. So let's take a look at this question. Let me see if I can snap this question. This was question 2. Yes, this was a very, very, very tricky question. So let me make sure I had the correct answer here. Let me snap this question. Alright, let's bring it up on the screen so that you all can see. Which of the following expressions is an example of scientific notation? Right, so scientific notation, and you notice the major wrong answer was A. Now, anybody can tell me what's wrong with A here? What's wrong with A here? Alright, Akila, I heard you have to leave in a little bit. So I see 9 people, the reviews normally climb up to about 30, 40. And by the end of the week, 100 and change. So why is A the wrong answer? Remember, this is scientific notation you're looking for. Why is A the wrong answer? The 10. Very good, Christian. So you see this 10 here? That's a problem. This number here must be a single digit number. Very good. And then a point. So the number could be 1.0. The number could even be 9.123, but it must be a single digit before the point. So the fact that it have 10 here makes this one wrong. And you'll see actually 36% of people got this one wrong picking this answer. Just a few people thought B was the answer. B can't be the answer because this number here has to be 10, right? And this is nothing at all. This is significant figures, but some people still fall for that significant figures trap. This is significant figures. The question is asking for scientific notation, and this here is the correct answer because we have a single digit. We have the 10, and it's okay if we have 10 there as well. That could be any number as a matter of fact at the top there. So let's get the next question. That was problematic. This one here was a scene. Which of the following numbers is a number written in base 2. So I made this one really, really tricky. And everybody fall for the trick. Alright, you can see the numbers here actually. Right? So the correct answer is actually 1. 1 is a number that can be in base 2. Because remember, the first number was 0, then 1, then 1, 0, then 1, 1. So this is actually a number that is in base 2. None of the other numbers can be in base 2 simply because base 2 does not have a 2 in it. So this was the next common one that people choose. But it's not correct because once you're talking about a number in base 2, you can't write 2. Only 1s and 0s. So this is a next tricky question, and a good few people fall in the pit. So now you know what to look out for in terms of what is a base 2 number. These are like the multiple choice that CXC may be forced to bring next year because we decimate multiple choices this year. Alright, let's look at two more, the two other tough questions. Two or one more? Two more, I think. One more. Not this one, not this one. I just snapped that. Which one is it? Is it this? Yes. This. Good night, everybody. We're just going over some of the pitfalls in the quiz. So we're in the last pitfall, the last problematic question here. So writing a number in which of the following is not a form of approximation? Now most people got it correct, but for those who didn't get this out, all of these here are approximation methods. When you write a number to a given decimal point, you're approximating up to that point. When you write a number correct to significant figures, you're erasing some numbers and you're just taking the important ones. When you're writing a number to a place value, you're just taking up to a certain place value, so you're approximating in all of these. The only time you're not approximating is when you use scientific notation. So those are the three questions in the quiz that gave the most problems. For the 15 people here, you could press Y in the chat if you are okay with this now. Look out for some more quizzes and actual exercises as well to do this week, especially during this holiday time. I'll be busy tonight. I was supposed to write up stuff today, but I was pretty busy as well today. So look out for that by tomorrow. Tomorrow, please God. Alright, so let's get into today's class. Today's class, we have a lot of stuff to cover. Here's what we're covering in today's class. We already did the homework review, so that's good. We want to do indices, and remember we're going from the syllabus, so we'll be going through the entire thing. We want to do ratios and proportions, which starting to really show themselves in CXC these days. Proportions, not so much proportions. Proportions probably never really see that, but indices. Profit and loss. Well, from here we enter the land of consumer arithmetic, and this might take us 2 or 3 more classes, right? So this might take us straight into the holidays, consumer arithmetic, and that will mean we are totally prepared for question 1 out of 10 questions in the CSEC Maths Paper 2. We want to also do a bit of tax, talk a bit of discount. I didn't put it in the group, but we want to talk a little bit about CP and SP and I forgot the next one. So cost price, selling price, and MP, marked price. We want to talk about the difference between those three. Really tie up students. These things really tie up some students. Cost price versus selling price versus something called mark price. That mark price, you see when that mark price come down into the dance, people just lose marks silly. Alright, so we're going to look at these for sure for this evening. Maybe if we finish and we do enough questions and I feel like everybody understand, we may go into higher purchase and simple interest and compound interest, SI and CI compound interest, right? So this is a maybe here. So for sure we want to try and cover all of these here. Alright, so let's start off with indices. Indices speak about the part of maths where we put numbers above another number. So if I have 2 and I put a number up there, like let's say 3, what does that tell us? It tells us that that 2 is being multiplied by itself 3 times. It goes like this: 2 by 2 by 2. Now that's simple enough, and you can work out that 2 by 2 by 2. 2 by 2 is 4 by 2 is 8. You can actually work out that. But do you know how exciting and interesting this can get, especially when you're going to algebra? This part needs to really be understood. Remember, maths is like building a house, and we are starting off with the foundation here. You see this indices? This is a big block in the foundation here, because we're going to start to put up the wall, and the wall is algebra. So you see this indices. If you don't understand indices well, when it comes into algebra and factorizing and the opposite of factorizing, expanding, you will get some problems. You get some problems. So make sure you understand, ask questions, stop me if you need to stop me in this, right? Now, so this is the basic of indices here. You put a number up there and it tells us how much time to multiply the number down there. Okay, let me show you what I mean. If I put a box here and I put a number up here like 4, it means this box needs to come and multiply by itself 4 times. Right? Straightforward enough. Understand the concept really good. Now, because of the whole nature of this, by the way, you can't find an answer here. Like before, we found an answer 8. Everything in maths wouldn't always give you an answer like a number. Sometimes the answer stops right there. That's the answer. That's as far as we could go. That's where you're getting your marks up to there. When you're a little weak in maths, you just try to just give an answer for everything. So like in algebra, and they tell you to expand something, and you just and then all of a sudden I see a number 18. Where that come out from? You're just supposed to reach up to the expansion part and stop. Don't try and train any numbers if you can't reach any numbers, right? Alright, so indices, what happens in indices is start to give you some laws. So let's just jump right into it. Let's just jump right into all the laws you could get in indices. Bam. Those are all the laws you can get there for CSEC maths. Laws, rules, whatever you want to call them. Those are those fellas there. So let's go through them one by one. You'll get some little questions in between, and then in the end you'll get a group question. You'll get questions involving all the laws. And that is the basics of indices there. Now, what happens when you see these X and these symbols, and everything starts to become fuzzy, and you start to zone out, and you're like, in your maths class in school, right? But let's take it one at a time. I don't know if you remember me saying this in last class. I said the legend says that any number to the power of 0 is 1. I'm not supposed to talk too loud today because I might have to sing in these people grads that song that I released. Alright, so let me make sure my voice in mashup. Alright, so x to the power of 0 is 1. Who was the last person to comment? Sherry Ann. Sherry to the power of 0 is 1. Anything to the power of 0 is 1. P to the power of 0 is 1. 10 to the power of 0 is 1. You could type it on your calculator. Any number, 2.65312 to the power of 0 is 1. Any number to the power of 0 is 1. You know why? Indices works like this. When I say 3 to the power of 4, I mean 1 times 3 times 3 times 3 times 3. Normally, we don't even put this 1. Okay, let me show you what's happening here. If I put 3 to the power of 3, I mean 1 times 3 times 3 times 3. Are you seeing that I put 3 times here? If I put 3 to the power of 2, it means 1 times 3 times 3. And pretty soon, I don't know if you're seeing what's going to occur here. I must make you small and send you up in the corner there. You see what's going to happen here? 3 to the power of 1 is going to be 1 times 3. By the way, this is 3. So any number to the power of 1 is itself, which is the second rule. Come into that. But if I do 3 to the power of 0, all of a sudden I have no more 3's. So 3 to the power of 0 is 1. That's how indices work, and that's how you need to think about it. Store it in your brain like that. And get some of the shine off my head here. Right? So any number to the power of 0 is 1. When you reach with a number and you have 0 on top is 1. And this shows up in one set of different ways in maths, and you just need to be comfortable with that. So let's move on. Next rule. Any number to the power of 1, they don't have it here, but that should be a rule as well. So let me just squeeze it in. Any number to the power of 1 is actually itself. Any number to the power of 1 is itself. And that means, basically means if I have 10 to the power of 1 is 10. Sherelle, let's see, she understands it now. So Sherelle to the power of 1 is Sherelle. Any number to the power of 1 is itself, what it was. Anything to the power of 1. X to the power of 1 is X. You know, when we start to use letters and names and any symbol, we just using it to replace a number. Something called algebra, right? Y to the power of 1 is Y. But what is Y to the power of 0? 1. Any number to the power of 0 is 1. But any number to the power of 1 is itself. Okay? So we're building up some ground here. We're building up some ground here. So let's take a little quick exercise just to make sure everybody on the same page. It's simple, but I want to make sure everybody on the same page. Let's get the answers for these. 100 to the power of 0, 2 to the power of 1, 1 to the power of 0 divided by 2. Let's get some answers. Let's get some answers in the chat. Answers for number 1, number 2, and number 3. The first one is 1, because any number to the power of 0 is 1. The second one is 2, because any number to the power of 1 is itself. The third one, let's see, I've seen people say the third one is 1. Those who said the third one is 1 left out this. So you'll have to do it like this. Any number to the power of 0 is 1, but then I put over 2. So the third one, because this over 2 came from here, the third one is actually a half. So shout out to all the people who pull out the half. And the last one, I'm seeing people putting answers for the last one. That's correct. The last one is 6, because we have 6 to the power of 1 being itself. Any number to the power of 1 is itself. So I put back the 6. Any number to the power of 0 is 1. So that's 6 over 1, which is the same as 6. So cool. You see how in maths they teach you one thing and then give you a little extra little tidbits in the end, and that's where you have to start to click up there. So you need to click up there as fast as possible. Let's go on to the next rule, or the nada rule. The nada rule. Alright, so this is where it starts to get tricky. We introduce negative negative numbers, and some people don't like negative numbers and they don't like fractions. So as soon as you understand something in maths, we pelt in some negative numbers, we pelt in some fractions to make the thing good, right? What does negative numbers do in indices? What does negative numbers do? Well, this is what negative numbers do. If you have a number, let's use 2, since 2 get and use a lot tonight, and we put it to the power of 2, it actually means 2 times 2. But if we put the number 2 to the power of negative 2, it actually means 1 over 2 times 2. 1 over 2 times 2. So that's what it means. It means if you see that negative sign and you're dealing with an index, it means those numbers are on the underneath. It's on the underneath. Let's examine that a little more, because that's something really interesting. This means, hey iPad, now is not the time for this kind of behavior, boy. Right. This means if we have, this means if we have like 3 to the power of negative 1. Any number to the power of 1 is itself. So this is really 3. No, it's not 3 because it has the negative. So it needs to be under the 1, but you just put the 3 like that. So that's what I'm saying. So 3 to the power of negative 1 is actually a third. That's interesting. Yeah, it is. I don't want you to think just division really. I want you to think it's under a 1. It starts to go into a fraction land. It starts to go into a fraction. It goes into a fraction. It's actually like this. If I have 5 to the power of negative, let's say 3, it means this is 1 over 5. 3 times 1 over 5 times 1 over 5. It goes into the fraction land like that. 1. Notice this number is always 1. But the shortcut way to write that whole thing is, since 1 is on top, I can just put 1 for all of them and put 5 by 5 by 5. Right? I'll loosen here, do it again, repeat it again, say the negative rule. Yeah, okay, no problem. So the positive rule just says multiply. So if I have like 6 to the power of 5, it says 6 by 6 by 6 by 6 by 6. 5 times. But if I just put a negative sign there, it means bam. Bam, this whole thing going to come under 1. Whole thing. So 5 negative 0 is 5. Ooh, you're asking some tough questions there, bro. So if you mean this 5 to the power of negative 0, well, in maths, there's nothing like negative 0. So if you have takeaway 0 is the same, negative 0 is the same thing as positive 0. So you don't need to really, that's why I just, let me show you what I write there. Sometimes I forget on the screen and just write it. Right, so you don't need to worry about that. Yes, you're correct. It's going to be 1. Well, yeah, I think you say 5. Well, you're wrong there. It's going to be 1 because anything to the power of 0 is 1. So you can ignore the negative sign and just anything to the power of 0 is 1. But the second you have like a number here and you put a negative, remember you don't have 5 by 5 by 5. You can't just leave it like that. You need to push this down and put it over 1 because of the negative sign. That's how it works. That's just how it works. That's just how the cookie crumbles. So if you have a negative, now watch how the rule says it. Let's see if we can understand why the rule is written how it is. The rule is saying x to the power of negative n. N here means the indexer. Very good, Julian. Very good. Reciprocal. It is the reciprocal. X to the negative n says put 1 over x to the n, and that's exactly what it means. That's exactly what it means. It says, hey, good thing is digital paper because I real reason. It says 5 to the power of like negative 2 is the same as 1 over 5 to the power of 2. So if I want to not have the negative sign, it needs to come underneath, which is the same as 1 over 5 by 5. Alright, so let's try some questions on this one, since this one was a little antsy. So what is the value of 2 to negative 3? And I'll give you some answers to pick from. So is it 2 by 2 by 2? Is it 2? 1 by 1 by 1? Is it 1 or 2 by 2 by 2 by 2? Or is it 1 or 2 by 2? 2. So 2 2 to the power negative 4. So some people say C, and then some people say D. But I guess people say C early because they probably see me reach here and then see me pay the last number. So the answer is D. And what would be the answer for number 2? What would be the answer for number 2 then? The answer for number 2, yes, will be C. Right? Because we have 4 here, so it means 4 on the underneath. Now, where this starts to get, yes, great. Where this starts to get really interesting, it starts to get really interesting when we include the next few rules. So, this is where it starts to get, to me, to a person like me, this is where it starts to get fun. Now, I don't know if it will start to get fun for you. We'll see. You'll see what I mean when I say it starts to get fun. See if it starts to get fun for you. Alright, so let's just look at these two rules in one. If we have an index and an next index, notice you have the same base. This part is called the base. This part is called the index. Right? Let me just write on the side here. This is the base. The number on the bottom is the base. The number on top is the index. Especially for those who take in their notes and the pointers and stuff like that. You must always take your little pointer notes and thing. And then you do a million zillion questions on it. Which I'll have to give you back a million zillion questions this week. We just had a nice short fun quiz. Alright, so if you have the same base and this dot here actually means multiply. Don't worry about the dot. It doesn't mean like a decimal. It means multiply. So I explain all these little nitty-gritty things because these are some of the things math teacher overlook. You're accustomed with your dot and thing, and these little small things is true of students. So this means multiply. So x to the power of some index multiply by x to the power of a brand new index. If I want to know what it is, just add it up. I'm going to explain this thing in a very nice way just now, but hold that for now. If the same thing occurred now, you notice this is the same thing like this, except there's a division sign. That's the only difference. So if it changes that division sign, it means take away this time. Okay, let's explain what's happening here. Let's explain what is happening here, over here. What's happening here, Alia? If I have 2 to the power of 3 multiply by, let's say, 2 to the power of 4. This going to have real twos out here, but that's okay. 2 to the power of 3 times 2 to the power of 4. Watch what's happening here. I'm going to put it in color so you'll see clearly what's going on and how this rule comes into being. 2 to the power of 3 multiply, I put the multiply in black since that has nothing to do with anybody, and then you have 2 to the power of 4. Well, the first thing I need to do is put down the 2 to the power of 3, right? 2 to the power of 3 means 2 by 2 by 2. And then I have the multiply by 2 to the power of 4. 2 by 2 by 2 by 2. That's correct, Cheryl. So 2 by 2 by 2 multiply by 2 by 2 by 2. So what's really happening here? 1, 2, 3, 4, 5, 6, 7 2's. All multiply. Do you know we could just come and write this like 2 to the power of 7. But if we look across here, this is the magic. If we look across here, we would see that 7 is actually the sum of these two numbers. So what are you saying, Cohen? Are you saying that 2 to the power of 3 times 2 to the power of 4 is actually equal to 2 to the power of 3 plus 4? Yes, that's exactly what I am saying. And that's the rule. That is the rule. The rule is saying, I fed up scroll back all the way here. Let me put these rules on a new page. Bam, come back here, fellas. Where you are? Boom, bam, bing. So look all up there again. The rule is saying, and remember this just means multiply. If you're multiplying and you have n and m, remember n and m for us just now was 2 to the power of 3 times 2 to the power of 4. So n was 3 and m was 4. If you want to find the answer, just add them up. Just add them up. When the bases are the same, you add the powers. It is fun, right? So now what would happen if there was a division? Let's examine it again. So if I had 2 to the power of 4, I put in the 4 here this time, divided by 2 to the power of 3, okay? So let's do the 2 to the power of 4 first. I'm doing it in red. 2 by 2 by 2 by 2. And because it's divided, I'm going to put divided by 2 to the power of 3. 2 times 2 times 2. What's going to happen here? You're going to get some cancellations. Remember this? And all we get remaining is 2 by itself, which is also known as 2 to the power of 1. So what are you saying, Cohen? Are you saying if you are dividing and you have the same base, you could just subtract them? Yes, that's exactly what I'm saying. So 2 to the power of 4 divided by 2 to the power of 3, you subtract those bases, bam, you end up with your answer. And this is where it starts to get very, very, very interesting. I'll make some questions for you and you'll see what answer you can get. Now remember, when you put in the answer for me, you could just write it like 2, and you could use this symbol to the power of, let's say, negative, if you have to put negative 3 as an answer, negative 3. Ken, what's going on with you, brother? You're looking good all the while. Don't do that. So you could write your answer good on your keyboard, right? I'm making it sound easy. Yes, that's what I do because I'm Cohen Springer. All right, so find these answers here. 1. What is the value of 2 to the power of 5 divided by 2 to the power of 1? What is the value of x to the power of 4 multiplied by x? And you notice how I write my x's to differentiate them from the multiply sign, by x to the power of 5. Remember, when you're writing your answers, to write the number next there. With 1 is this. What is the value of 2 to the power of 10 divided by 2 to the power of 2? What is the value of 2 to the power of 2 divided by 2 to the power of 10 now? So remember, I told you it starts to get really interesting after a while. Number 5, what is the value of 6 to the power of 3 divided by 6 to the power of 3? What is the value of x to the power of 4 divided by x to the power of 3? Let's get those answers first. So number 1, everybody's saying 2 to the power of 4 for number 1. That's correct. So this is the working that you'll do when you're doing the homework for me. 2 to the power of 5 take away 1, which is equal to 2 to the power of 4. Now, I don't normally approve of equal signs going like this, but I ran it out of space. So really and truly, this would have been like 2 to the power of 5 take away 1, make that 5 look a little better, and then you put 2 to the power of 4 like this, right? But I'm running out of space, so I'm just going to put it going across. It's better to do your working going down. It's when the maths start to get crazy, it's better like that. 2, everybody's saying x to the power of 9, which is correct. So I'll just put the answer this time, but you know you're adding these two together, right? You need that line. I didn't put the line in between. This one, 3, very good. So sometimes you'll see divide like this, or sometimes you'll see this thing here, ventriculum. You know, I forget the name of that damn thing. And I pride myself in knowing everything in CSEC maths. What's the name of that thing, boy? Something column or something like that. Right, so it's 2 to the power of 10, take away 2, which is actually 2 to the power of 8. Let's see if anybody can remember the name of this thing here, or you can use Google. So I'm seeing people getting the answer for number 4, which is very good because number 4 goes into minus land. And this, or negative land, you have actually 2 to the power of the first number, 2, subtract 10 this time. And you know when you have a smaller number take away a bigger number, very likely you're going to end up in negative land. So 2 to the power of 2 take away 10, and we're going to do a whole class on directed numbers. It's actually negative 8. This one, number 5, is 1, because you have 6 to the power of 3, take away 3, which is equal to 6 to the power of 0, which is equal to 1. or anytime you're dividing and you have the same thing on the top and the bottom, it's just 1. See how important 6 to the power, anything going to the power of 0 means 1, right? So 6 to the power of 0 is actually 1. So that's why people are saying that. And this one is actually x, because this is x to the power of 4 take away 3, which is x to the power of 1, which is also known as x. Why is in the chat if you totally understand this? Type Y if you totally understand this. Now in algebra we'll be facing this again in something called expansion and factorizing. For example, we'll have something like this: x by x plus, okay, let's say x squared y. What is going to happen, and this is just a little idea of what's coming up, x by x, this is x to the power of 1 by x to the power of 1. So x by x, add those index, because remember you're multiplying across those brackets. All of a sudden you're going to get x squared here. And x to the power, then you have to multiply by this term here. So x by x squared, you're going to get x cubed y. So these techniques, as I said, they're building a house. Indices is that big block in the foundation that some people don't get at the beginning and run into problems. So don't be surprised if you see I give you about 50 indices questions to do. Do them all. I will give you the solutions. Check through the solutions. And then do over the ones you get wrong. Look up on YouTube for stuff on indices if you're weak in it, and make sure you get that foundational block in strong. All this information making me feel like I forget everything we learned so far. Let me pause and let me stop and let me take a look at what has happened. Now this happens in my class in school as well, because in the class in school I teach, the students are not very motivated because of the nature of the school. So because I think I'm a good teacher, so when I teach something, let's say this is 100%, most of the class, even the students who struggle, get pretty close to 100% in terms of knowledge. Let's say this is failure down here. Failure. This is 0, right? You know what this axis is here? Time. Time, as time progress. So in the beginning, everybody about at 100%. Go back to the last page. I'll go back to the last page just now. Everybody at 100%. And all of a sudden, as time progress, by the time the next day reach, people at about 50%, 50%, they forget all our breakdown, all our so nice, they feeling like stars in the class. You know? When I get them a test at the end of the week, people cracking 50%. Now, if I give my really top students, and then I give them a test the next month in lessons, like my students who go on to get scholarships, they're still at the 100%. Now, why are they still at the 100%? Because of something called, at this point, they do revision. So like this is one day after. But the person who didn't do revision will just keep going down until they reach failure. Pure failure. Because they didn't revise. What revision does is a magical thing. It takes it all the way back up. All of a sudden you hear my voice, you go through again, and it's very easy to revise on this, because you could just go back and play the live and wash the ways. You could play the live and plait your hair, all kind of thing. It goes back up to 100, but this time your brain loses the information much slower. And if you revise again one more time, maybe a week later, it goes up here and your brain keeps it. It keeps it pretty good. So with mathematics, with everything, you need a revision, especially if you're not naturally good at maths. Some people, what happen, they don't revise, like they don't actually pick up the book, but because math's so interesting to them, it plays over in their brain. When they're sleeping and they're thinking about it, it's so fun to them, so it relates to them, and that way they don't really need to revise because their brain thinking it over. So this happening with them automatically. But if it's not happening automatically, it will take some work. Just signing up to the class, kind of doing the homework not automatically guaranteeing you a 1. It will take some work on your part in revising and really understanding this stuff. Let's go back so big man can take a picture. I don't think it's this one you want to take a picture of. This is coming up. Coming up. Right? So maybe in the next 4 or 5 classes they will see expansion and algebra. This one, if you want to take it's probably this one you want to take a picture of. Alright, so snap your picture of that and let's move on. I just want to show you one more thing in indices that could happen. One more thing in indices. You can end up having to factorize. This is also coming up. So like if I have x to the power of 5 plus, let's say y by x to the power of 2. If you have to factorize, you need to come here and see what's common. And what's common here is actually x to the power of 2. So you can actually pull out an x squared. And now to figure out what term to put there is like the reverse of what we're doing just now. It's going to be x cubed because 2 plus 3 will give me back the 5 plus y. So that's how factorization works. Now notice nothing happened to the y. The y didn't change the square or anything because the y is different to the x. As Roseanne said, they're different beats, but I don't know if it's that what she's talking about. Okay? Alright, so let's go on. At the start of the class, we said we're doing these topics. So we finish homework review, we finish indices. Let's go on to ratios and proportions now. Ratios and proportions sets up itself to look like an easy, sweet topic. But then when you see the topic, you figure out like you feel like you can't do it. So I almost always teach ratios and proportion from a question perspective. So I give you a question, I'll give you a question and you'll have to try and figure it out. Alright, so Christian has and Rose have a total of $210. Let's put this in right because this is important. $210 shared in the ratio or proportion or ratio 2 to 5. Let's put that in red too because that's the next important information that I want you all to see. 2 to 5. How much money do they each have? How much money do they have individually? So I want the individual values. How would you do this question? By the way, can anybody figure out the answer? Let's see if we have some people who sharp on this topic. Christian and Rosanna, and I'll always try to give you all the topics that we're gonna do either on the same day or maybe the day or two before, so people can review what made me come. And that's the kind of person I was. I'm a very research person. And what made me come first a record number of times in my primary school was the fact that as soon as I get my textbook, as soon as my mother buy my textbook for me in August, I read through every single page of the textbook. We do every exercise and everything. Even if I do some stuff wrong, I really know it. So by the time you just start teaching the topic, I already hit it already. So it helps to actually, like if I put the topic before, that you go on Google and you try and take up a little thing on the topic, that is called prevision. And I always tell my students, especially the ones going for scholarships and stuff, prevision is actually stronger than revision. Prevision is you. So $60 for Christian and $150 for Roseanne. Well done, Danny. Well done. Christian have 2 out of 7. That's good. That means you're going down the right road. 150 for well done, Rashad. I didn't see your answer there. Well done. So it was me who messaged you for help with this topic. Wait. So I told you you was coming up to this. So right. So how do we do this? So the one thing I want you to hear in the back of your head all the time is find, for goodness sake, find for one. For goodness sake, find for one. This is the easy way the question could come. Question could come another way. It could come this way, mix up with like 3 people and thing, but it could come like this way, it could come another way. I'm not sure the next way just now. But the word I want you to remember, I want you to take this in your mind, for goodness sake, man. Find for one. Remember, Sir C. Find for one. Find for. I know right now, eh? For one. Find for one. That's gonna break it. My keyboard was sticking the week. Alright, so what do I mean by find for one? Let's see. Okay. You have $210 being shared in the ratio 2 to 5. Now you always watch which comes first here and what comes first here. So Christian has to be getting the 2 because his name is first. Roseanne, she's getting the 5. So hard luck by Christian, by Roseanne getting all the money. Right? So 2 to 5. This is how these steps go down. I don't know why I'm thinking going to the next thing. Alright, so we have $210. This is the total. What you need to find is for one. Find for one. The total the total amount of parts. The total amount of parts is what? So let's see if we can figure out this. Total number of parts. This is a working is equal to the 2 that Christian get plus the 5 that Roseanne got. So this is actually 7. So the aim in my mind is to find for one. This 7 parts actually is nothing with 1. This 7 parts. What does this 7 parts represent? This represents all. This represents the total number of parts. And the total number of parts, Christian money and Roseanne money, adds up to $210. So 7 parts represent $210. So I could write that. 7 parts equal 210. So therefore 1 part is going to be equal to how much? If 4 things equal $40, 4 items cost $40, then 1 item must be $10. How I got that? I divide. So if 7 parts equal 210, 1 part would be equal to 210 divided by 7. So, and this is what Sir said to do from here. Find for 1. And we come across here and boom, we are finding for 1. Well, why is this finding for 1 so important? Because it cracks the code. So we've 1 here actually represents 30. When you put that in your calculator, you'll see that, right? 7 into 210 is 30. So if I have for 1 part is $30, then I could come now and say, hey, 1 part equal $30. Therefore, Christian, who has Scranton 2 parts, Christian's 2 parts would be equal to 30 times 2, $60. And Roseanne, how much part she get? 5 parts would be equal to 30, because 30 is 1 times 5, which will be $150. Bam! Question solved. This is the one of the ways they can bring the question, where you find for 1 part based off of the whole total. They gave you how much money both of them had. Both of them had this 210, so you have to add up, get the total number of parts, divide to find for 1, and then multiply. So let's do a little quick recap. Christian and Roseanne have $210. So they share it up. So it means they share it up in a certain way. We see in 2 to 5. So it means as I gave Christian $2, I gave Roseanne $5. I gave him 2 more, I gave her 5 more. 2 more, 5 more until I run out of a big set of money here. So it's like I have a big stack of money here, and I gave him 2, 5, 2, 5, 2, 5, 2, 5. And they want to know how much they'll get in the end. That's the ratio. So there's a way to work this out, and the way to work this out is under the whole idea of finding for 1. So what do I mean by that? It means first I need to establish that the total is 210. Then I need to establish how many parts are they splitting up in all. There's 2, and then there's 5. 2 and 5 add up to give me 7. I need to take that 7 and divide it by the 210. Why? Because this 7 represents a total here, and the 210 is the total. So to find for 1 part, I need to say 210 divided by 7, and I'll find out how much 1 part represents. And since I have how much 1 part represents, how much part is Christian getting? He's getting 2 out of the 7. He's getting 2 out of the 7. But 2 times the 1 part. The 1 part is 30. So 2 times 30 is 60. She's getting 5. 5 times the 1 part. This is the formula. Yes. So 5 times the 1 part will be 150. Okay, let's look at the next question. I'll give you all a chance to figure it out. Let's look at the next question. Paul, and I'm putting in 3 people. This is how maths works, people. You understand one thing and immediately the teacher start pointing on the next thing down your throat. Paul, John, and George. My maths teacher is just be coming up with names right through. Shares up. Shares up. Alright. Bad English here, but we can live. Shares up. Let's say divides up. Divides. I don't need to say up. Divides. How much money, boy? Let's use money again. $640 in the ratio of let's make this ratio interesting. 3 to let's give you a big amount, to 9 to 4. 3 to 9 to 4. Okay. Find out how much each individual gets. So whip out your pen and your thing and start to get this down. So Paul, John, and George divides $640. The 640 kind of out the screen, but you can see the 640 in the ratio, and this is the ratio. So this means how much Paul getting, boy? Paul is getting 3 out of the ratio. John is getting 2, because remember I told you the order of how their names appear means the order of the ratio. So this is like 3 to 4. Whoa, somebody done the money there. Paul get 120. Well done. 3 people then out. 3. What? Rashad, clean it up. Well done. 120, 360, 160. That's good work, guys. Good work. Good work. So let me rush it. Since I'll be rushing it too, it means that we're understanding. So that's great. What? Let me write now. So that's good. Alright, so the total parts, so the total is 640. Total parts would be equal to, I forget what numbers I used. I think it was 3 plus 9 plus 4. Yeah. So this come up to 16, which is what the number I wanted. And therefore, and I'm going to do the magic here. one part would be equal, and this is the aim, this was my aim all along, 640 divided by 16. Calculator says that is $40. So now it's very easy. Once I have this $40, this represents one part, it's very easy for me to figure out the rest, because this is one part and everybody's getting a certain number of parts. Paul, he gets 3 parts, so he's going to get 40 times 3. Yeah, so somebody put 120, 360, 160. I don't know why I put positive signs between them, Ricardo. It should have commas like everybody else. So this is going to be 120. So this is Paul, yeah, and put a little dollar sign to make sure they didn't take away no mark for frivolous reasons. Then we're going to have John and George. John has 9 parts. So this is 9 times 40, which is 9 4s are 36. So this is 360. And then Georgie was on 4 parts. So this is 4 times 4. 4 times 4 is 16, so that's 160. And that's the end there. Perfect, right? So this is cool. This is cool. Remember, the key here is finding for one part. Now, this style of question comes exactly like that, what I just gave you there. Exactly like that for CXC, or the other way. Another way it can come. I'm going to show you that right now. Here's the other way it can come, guys. This way is a little more tricky, but you still need to keep in mind, find for one. Alright, let's check it out. Let's see, Jennifer and Pauline split up $1,200. Hold on there, my mother calling me. She the big. Hello? Yeah. Long time. In Nathan room? Oh no. Right. I live on YouTube. I hope my volume not too loud, because yeah. I hope no volume not too loud, otherwise they tell the whole of the YouTube how to get in the house. Nothing. I gone. I will check it out. Yeah. Yeah, so I hope I didn't hear that. I'll go and do some stuff. Alright, so Jennifer and Pauline split up. Yeah, in the middle of our question here, boy. Sorry about that. What time we finishing? So we finishing about 20 to 9, quarter to 9. We start a little early today, so we could finish a little early too. Alright, so Jennifer and Pauline split up this amount of money. And are we getting homework on this topic? Yes. We get homework on everything. We always get homework on everything we do. My word, love the humor. Liz, you make her appearance. That first appearance for the night day, boy. To compliment my humor. I'll take it. Alright, Jennifer and Pauline split up 1200 in the ratio of, let's use a ratio like this. 7 scratch everything. Don't scratch everything, Corinne. Don't scratch everything. I just realized I'm doing another style of question. So what they'll do is say Jennifer and Pauline, sorry about that, guys. Jennifer and Pauline split up a sum of money. So they wouldn't tell you how much money they split up. This is the other way the question could come. In the ratio let's see, 4 to 7. 4 to 7. So they give you the ratio and they give you the sum of money. And they did, but they didn't give you the sum of money. And here's what else they give you. They'll always give you two pieces of information. If Jennifer got $44, how, let's not make a 44, let's make about $88. How much does Pauline get? Right? Sorry about the handwriting, as the live go on, like the handwriting is just go away. Right? So spelling Jennifer name different every time, but Jennifer. Right, so what is happening here? How do we do a question like this? Somebody done hit them the correct answer there. Well done, Raphael. Pauline get 56. No, because remember, Pauline on the bigger side of the ratio, Pauline gets 7 and this person get 4. So you know that answer can't be correct. Because if this person get 88, it means Pauline had to get more, Jennifer, right? So Rashad didn't hit them good this time, they brother. You was first on the ranks for so much time. Danny, well done. So it is 154. So those guys were at 154. So how do we do a question like this? Keep in mind all the time I'm using numbers to give you solid answers, right? In the end, when we finish, I'll just give you a number that will give you decimal points, just to make sure that I can do it. If you get decimal points, you use your calculator, however. But all these numbers I'm picking in my mind, I'm doing the question in my mind to try and make sure that it works out nicely. Alright, so how do we do this question? What did I say is the magic thing that you need to do? Find for 1. But how are we going to find for 1 here if we don't know the total sum? So we can't divide by 4 plus 7 is 11. We can't divide by anything here. So what do we do? What do we do, sir? Well, what you need to do, if they don't give you the sum and they give you the ratio and how much one person get, you need to work with that information. Very good, Jody. So you need to work with that information. You're saying here, Jennifer. Very good, Jody. And they said Jennifer got $88. What part of the ratio does this represent? This represents the 4. The 4 in the ratio. So in other words, 4 parts represents $88. So that's what you need to use now. So you need to say, Jennifer, you're not starting off with the total now, you're starting off with this person, because they gave this money. So Jennifer got $80. But Jennifer has 4 parts. 4 parts of the ratio must be equal to that $80. So how much is 1 part? Because the aim in real life, when you start this question, you need to ask yourself, what is the aim in my life here, boy? By the way, it was 88. 88. I'll put 80. You need to ask yourself, what is the aim in my life? The aim in my life is to find for 1. So 88 divided by 4 is the answer, which is 22. Technically, I'm not supposed to have S there. So $22. So you use the information given to still come back in the end and find for 1 part. Now, you ain't done yet, but you're good to go there. How much does Pauline get? All you need to do now is say Pauline has 7 parts. So it's very easy to work out how much Pauline gets. Pauline would get 7, and I'll put 7 parts here so you see what I mean. Pauline will get 7 times this 22, which is 154. Pauline gets the $154. And they could ask you how much they get in all. Well, you just add Jennifer and Pauline money together. Or you could have added up this. 4 plus 7 is 11, and multiply 11 by the 22, and you will have your answer. So why is in the chat if you understand everything there? So those are the 2 main ways that a ratio question can come. The other way a ratio question can come, the last way, which it can come, which is kind of easy in a way, but I need to say it because I'm going to do everything. It is, so we did what happens if they give you the total and the ratio to find out stuff. They give you the total, like when we had 210 and we had 34 and we call stuff. Then we just do what happens if they don't give you the total, or they give you how much one person gets and the ratio. What about if they don't give you the ratio at all, and they give you how much individually they get and what it is? Well, that's kind of simple, but that has to deal with the proportion. That's where the word proportion comes into play, which is why they don't really bring it. But let's for example, if they say Jada and Shanna have 10,000, 1,000 followers on Insta. If Jada has 625, what is the ratio? Jada has 625 followers. What is the ratio? And I'm going to finish the end of the question. You understand what I mean? What is the ratio of followers? I need to finish actually. I need to say who first. Ratio of followers, Jada to Shanna. Why is 88 divided by 4? Good question. Because here, look out for the parts are circling in red, right? Jennifer and Pauline, Jennifer and Pauline, Jennifer and Pauline. Jennifer means 4. Jennifer is getting 4 parts. If Jennifer gets 88, it means that her 4 parts gave her $88. So 4 parts means $88. So 1 part would mean 88 divided by 4. So that's how we divide by 4 to find for 1 part there. So what is the ratio? And this is the next way the question can come. So they gave you Jada and Shanna, trying to be as hard as possible in the question. Jada and Shanna have 1,000 followers on Instagram. If Jada has 625 followers, what is the ratio of the followers? Jada to Shanna. Jada to Shanna. That answer can be correct because Jada has 625, which means she has a bigger number out of 1,000. Right? So she has 625. So what you need to do is fractions. So this one is not really finding for one. This one is fractions or proportion. Proportion 5 to 3. That's something a little better. Proportion says that like if I have 6 over 8, that is the same as 3 over 4. You can break it down. So fractions break down. So all I'm saying is if I want the ratio of Jada to Shanna, this means Jada. Another way you could write it is Jada over Shanna. Like this. Jada over Shanna. So Jada to Shanna. And how much Jada gets? 625. So how much Shanna is getting now? How much Shanna is getting now, guys? Well, they said that they have 1,000 in all. So it means Shanna has 1,000 take away 625. 1,000 take away 625 is 375. Right? So Shanna has 375. And then you break this down the best way possible. Oh yeah, some people puzzled. Remember Jada has 625 followers and Shanna has 375 followers. Now the question didn't say how much Shanna have, but they give you how much you have all together. I just made it that way so in case it come that way as complicated as possible. So what you need to do is put it as a fraction form. and break it down. Now, this calculator could actually do that. You just type 625 over 375 and press equal, and it actually puts it in the simplest. I don't know how much you can see there, but it actually break it down one time, right? So you didn't need to actually go and come now and say, break down this, brother. All right, 25 into this how much times and da 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 like that. All right, so if I had say 25 into it, 625 divided by 25, so I get 20. 625 divided by 25, and I get 25 here, and 375 divided by 25, and I get 15 here. So some people getting some right here, right? And then I'd break it down by 5 here, and I'll get 5, and then I break it down, I get 3. So the answer is actually 5 over 3. Now, this is not really the answer because it's a fraction. Now, you might still get the mark, but they more likely want to see Jada to Shana. Jada to Shana means the ratio 5 to 3. 1.6 is not correct. You could never put that. Christian, never ever work it out. Never work it out. It's not decimals. It's a fraction or a ratio like this. If you work it out, it lost meaning. It lost the meaning of what you're trying to say. Understand? Alright, so we're gonna get 3 questions on this. By the way, this brings us kind of to the end of the first part in question 1, where I give you the 3 questions on this. And we are a little past halfway into the class, so we'll be starting a bit of consumer arithmetic, and we'll be engaging in some profit and loss, tax, discount, cost price, selling price, and marked price. So brace yourself, we're going to do that in a little bit, but let's just get these 3 questions down. Now, I already foresee after I finish consumer arithmetic, I'm going to do maybe 1, maybe 2 classes reviewing everything in question 1 again to kind of bring it together. Because we have time. I started this class in June. I kind of do that so we could get a little more time and be completely ready for me. So I'll get a little time to help you revise. Because one of the problem with weak math students is they just don't have, I keep saying this, the math stamina. So you all need the motivation. Watching me do it and stuff easier than actually revising. So I'll kind of help you that way. Alright. Let's get these 3 questions done. No more long talking. 1. Mine gone blank. Right, cool. And John share up 250 in the ratio 19 to 6. And how much each individual gets. So January maths need a timeline too. So will you finish everything by January? Not everything. It'll be pretty good for Jan. It'll be pretty good for Jan, but it'll be better for me, obviously. I'll have more time to revise and things. But what will happen? Well, what will most likely happen is during Christmas. By the way, people who doing January exam, there's not no Christmas or nothing like that. It'll be like the 25th Christmas, Boxing Day, all them time when people drinking and thing, you had to be sit down beating out maths. I know this because I was in the hostel with a host of students. Ole's night and thing, maths for you, brother, bright and early on January, boom bang, it's just the maths exam. So during that time, what will happen to make sure that I meet up, but this will be public, I will have some public crash courses on my YouTube for everybody, and that will help like for the last bit of the course, which I wouldn't yet complete, but I will complete for those who doing it in May. That will help. So you'll basically have everything for January, but it'll be better for the May. So yes, the course is targeted for the May, but I will obviously help you all for the January people. Or you'll get the answer if you didn't write it as yet. Yeah, I done write the first one. So 2 people in stick, people done the first one. But like, why is it talking? Let me just kill off that. Number 2, a number of pigeons in Park A and Park B. If Peter counted 180. Now, but he can't count that amount. Let me make it a little realistic. 66 in Park A and the ratio is 7 to 15. 2 parts to this question here. Go ahead and squeeze it in this little box on here. 2 parts in this question, right? So part A is how much in Part B. Hope you can see that. Sorry. How much in Part B? And what's the next question? How many in all? How many in all? I'm not supposed to say how much. I'm supposed to say how many. That's bad English. How many? How many in Part B? So let me just read the question again. There are a number of pigeons in Park A and Park B. If Peter counted 66 pigeons in Park A and the ratio is 7 to 15, how many in Park B? So you spell pigeon wrong? Damn it. Hey, I teach in maths. So you spell pigeon. So I teach in maths and English. So, yeah. For real, I put pidge on. So it had no spelling like that? Come on, and tell me I can spell it like this too now. Damn it, man. Old English, you could spell it like that. So there's that. Part B, I seen people racing through. Somebody get A was 21 and 45. What? Not too sure about that. I don't even know where that come from. Those are the first 2 questions. I see most people get the answer for number 1 already. Well, not most people, because that's 34 people here, not everybody answering. But I've seen a lot of people get the answer for number 1. With the 190 and 60, and yes, that makes sense. So what you need to do is add up these 2. 19 and 6, and you'll get 25. Then you divide into there. You'll get 25 into 250 is 10. So 19 by 10 is 190, and 60 by 10, 6 by 10 is 60. So that's good. So number 1 is good. And 141 in all, 207 in all. That's what you get. Times. I need my calculator here. 60, 141. You're getting a point. You're getting 141.42. So she estimate 141 because it's not like you're gonna get half a pigeon unless somebody cut a pigeon off and thing, right? So okay, I'll go with the 141. So that was actually correct. Well done, Danny. And then 15. What the hell I do? So 141 plus 66. 141 plus 66. 207 in all. That's great. So I'm waiting for more people to put the answer. Anybody else got figured out that one? Anybody else figured out that one? So these people want me to show up in their guards, and I don't really have no clothes and anything, so I just go and show up normal. Oh yes, what is love? Somebody say no, that wrong. So it's probably, oh, that's the pigeon. That's the whole pigeon thing. People, y'all getting problems with this one? Let me see some Y's in the chat. Rain start to fall. I hope that don't affect the quality of the live. You know, when rain falls, sometimes the line, the line is messed up. Anybody else get it out? Right, Ricardo. So y'all hearing that as you read. Good thing I start earlier, I mean, yes. What that nope mean? Nope, you ain't get it out. Problems. So, y'all want me to do this one? Do number 2? Alright, I'll do number 2. So, by the way, this is exactly like this. What did Jennifer question? This question. It's exactly like this question, right? But in maths, they will change up wording and stuff like that. So you need to be comfortable with changing up the wording. Okay, let's look it up. So it says in Park A, there was 66. Now I just put in Peter to try this, put in other variable. But Peter had nothing to do with anything. He was just the guy who counted, right? So don't worry about Peter. So in Park A, there was 66 pigeons. How many parts are this? How many parts does this represent? 7, right? So 7 parts. You all hear me, right? 7 parts because the rain falling real loud. 7 parts would be $66. 66. I'm going to put dollars, but it's pigeons. So 1 part would be 66 over 7. Yes, well done. Well done, Jill. Which people are going to be 9.43, but I'm not even going to put whatever it is. I'm just going to leave it like that. That is how much 1 part means. So if I want to work out how much part B is getting, it's going to be 15 times that times the 1 part. Remember, this was the whole aim of the game, finding for 1. So 15 times 66 over 7. Work that out. 15 times 66 over 7. And that's going to give you 141.4. But since we deal with pigeons, I can't put 0.4. So I just need to put 1.41. 141. Right? Yeah. And then in all, I'll add up the 2 numbers in the part. So it'll be 66 plus 141. Which is 66 plus 141. 207 pigeons. Spell it correct this time. That's it. Alright. One last look at this. You all will get the homework question. One last question. What is the ratio of the height of the two buildings below? So what's the ratio of the height of the two buildings below? And I'm going to draw the buildings. This one, why that building had to come out then from this one and this one. Let's give them a height. Let's say that this building is actually 170 meters, let's say 160 meters, and this building is actually 36 meters. I know it don't look so, but let me pretend, right? 36 meters. So what is the ratio of the heights of the two buildings? And I'll call it, just so that you can name it properly, building A and building B. Why is 66 divided by 7 instead of 15? 66, because Park A, if Peter counted 66 in Park A and the ratio is 7 to 15, Park A to Park B, 7 to 15. If I divide by 15, I have to do it Park B. So I have to divide by 7 because I'm talking about Park A. So the 66 is being divided by 7 because there are 7 parts in Park A, not 15 parts. The 15 is for Park B. I hope you get that. I was talking kind of down like this, but I hope you get what I just said. So, what is the ratio of the two buildings? Waiting for a solid answer for this one. So I want building A to building B. Oh boy, they were at a sleep, boy. Building B. Right now, my kids into somebody say 40 to 9. I hope that's the correct answer. That's sounding reasonable. Right now, my wife and my 2 children in Tobago, so I hope them having fun there. That's me alone. Building A to building B. 40 to 9, 40 to 9. Well done, Ricardo. Well done, Danny. Starting to see the usual suspects, the early birds. Christian, nice. So this is like the proportion part. This is like the last question that we mentioned. So all you need to do is set it up in the, like this, 160 to 36, and then you try and break it down in the smallest possible way. So what I think most people tried was 4 into that is actually 40, and 4 into 36 is actually 9. This is where you can use a calculator. And then you don't try to solve this, you come back and you say 40 to 9, and that's the answer. So look out for it in homework. Make sure you can do it. Let's take a quick recap before we go into a little bit of consumer arithmetic. So we started off. These kind of questions are usually worth 2 to 3 marks. And they start off in the beginning of the paper. It doesn't be good to lose marks in these questions because they feel like a bake for the whole rest of the paper, and it doesn't be in good spirits. This will be the first question. Sometimes it comes in question 2 or question 7 as well. Yeah, so you can see you just type it and you get it. So we went through the tough questions in the homework. This was the one that was done the worst, I think, the scientific notation question. So we went through why. Because you can't have the number 10 there, you need to have a single number. We went through the other questions. Okay, this one was done poorly as well. This has the number 2 in it. If you're dealing with base 2, you could only have 1s and 0s. So which one of these only have 1s and 0s? Actually, this one. Which one is not a form of approximation? too many people put the wrong answers here. Yes, what this graph is showing is how much people put the wrong answer to the correct answer, which is useful to me, so I can get to know quickly who is which question giving the most trouble, right, with one glance. And so I just verify that the only thing that is not a form of approximation is just writing in scientific notation. All of these are approximation here. We finished ratio and proportions. This is just a roadmap of what we're doing for today. And I said we're going to try and get in these guys. We have about 30 to 35 minutes to try and get in these guys to talk about them: profit and loss, tax, discount, cost price, and selling price, and mark price. The good thing about it, this is like the foundation for consumer arithmetic. These are the beginning topics in consumer arithmetic. Right? So we went through indices. We went through like the concept of indices, why it's really important that you totally understand indices. So did you get the list of schools that letting us do the SBA? Sorry, I didn't get the list of schools that letting you all do the SBA. But whilst I was talking about it in the group, people mentioned them in Trinidad. I mentioned some of the list of schools in Trinidad that will allow you to do SBA. All I know so far is CTS. Right, in Shoguners. So we went through concepts in this, and then we went through the laws of indices. And we went through each law, this one, this one, this one, this one, this one. Oh my god. We left out these two laws. Right? So we left out these two laws. Alright, so yeah, the touchback, them two laws, people, we coming back to earlier, fellas. Sorry for leaving on the out by. Whoa. But by the way, most of maths comes on these two laws, and that's why I was so happy I just went on one time. So we left out these two laws here. Nobody realized we left out them two laws, right? They're kind of important too, you know. Right, so we went through the first law where anything to the power of 0 is 1, then anything to the power of 1 is itself. Then we did some exercises on those laws. Went through this law that says if you have a negative number, it means bring this stuff on the underneath. Then we started up with the addition laws and the subtraction laws. If you're dividing, it means you're subtracting. If you're multiplying, it means you are adding. And then we forgot our two laws and we went straight into revision techniques. We went into where indices could take us in terms of factorizing and stuff like that. Then we went into the ratios, which is what we was just doing there. I showed you there's 3 ways the ratio question could come. There's this way, which is this is still the same way. And there's this way, the way with Jennifer I showed you, like if you wasn't given the whole part, but you're given how much one person get. And then there's this way, if they didn't give you the ratio at all and you had to find the ratio. Then I went on to give you 3 questions on it. This is the first way, this is the second way here, and this is the third way in a graphical kind of question, right? So they give you the building, it in buildings. So let me backtrack. So we're losing some time in consumer arithmetic there, but that's okay. We have time. Missing indices laws. Missing indices laws. So the laws that I missed out was the complicated laws and indices, the weird guys. So if I have 2 to the power of 3 and I decide I want to bracket up this whole thing and raise it to another power again, 2 to the power of, let's make it the same number, 4. So let's take this, right? We have 2 to the power of, boy, them numbers too big, boy. So we say 2 to the power of 2, because I actually want to show you exactly what happened in so I want to go with them numbers. And then I raise it to a new power again, to the power of just 3, right? 2 to the power of 2. Then I raise this whole system to the power of 3 again. What does that mean? And what does that do? Do I add the indices like last time? Do I multiply them? What do I do? Well, you actually multiply them. The answer is 2 to the power of 6. You have to multiply 2 by the 3 when it's like this. Well, let me show you why. I'm going to put the first thing in red. 2 to the power of 2 means 2 by 2. Now, if I'm saying 2 to the power of 2 raised to the power of 3, it means I need to write this 3 times. Hope I ain't lost anybody there. So 2 to the power of 2, then I have to raise that to the power of 3. It means 2 to the power of 2 means 2 by 2, because 2 times. You do the brackets here, you do the brackets first for real. 2 by 2, and then raise it to the power of 3. So let's just get that. It means I need to do this 3 times. 2 to the power of 2, and the next one 2 to the power of 2. And put some multiply in between. This is 1, 2, 3 times, which is good. Now, how many 2's do I have here? 1, 2, 3, 4, 5, 6. So that's why that is the answer. So that law says that if I have 2 to the power of like 5 and I put 10 here, it actually means that's really 2 to the power of 50. I need to multiply when it's like this. So the law is written in this way. Hey, I'm not going to scroll all the way back for them laws. Let's bring them up again. The law is written in a nice way here. You seen it? Let's make it nice and big. We did this one already, so we're looking at these two. The law is written. Yeah, the law is written in a nice way here. It's actually saying that if I have x to the power of n and I have to raise that to the power of m, I need to multiply the 2. Remember I told you the dot here just means multiply, so it means multiply the 2. So if I have that bracket and I raise it at next power, multiply the 2. This is the trickiest of them all. This is the final law, the trickiest of them all. Some weird stuff is happening with this law. Let me show you what I mean. This is what this law solves for us. What about if I had 16 to the power of a half? What does that do? What does that do? So all the time I was raising to whole numbers, all the time I was raising to like 16 to the power of 2, and I even raised to a negative number already. We did that law already. What would happen if it was a negative number? 1 over 16 by 16, right? I just write 16 by 16 there. 1 over 16 by 16. So that's how it would look. But that's not what's going on here. What's happening here? We're actually raising to a fraction. Here's what's going on here, people. If you raise something to a fraction, you see this number underneath here, the denominator. That's actually going to become the root. It's weird, but it's what's going on. So this is actually going to become the root of 16. And what is the square root of 16? So the answer is like 4 here. This is the weirdest this is the weirdest thing ever. It could get even weirder. Like if I have, let's say I had 125 to the power of a third, and I just put it in brackets so you can see I clearly raising that to the power of a third. It means this becomes the root here, and this is actually going to be the cube root of 125. And I choose the number 125 because 125 was a nice cube root. The cube root of 125 is actually 5. Now let me give you some questions and see if you can figure it out, see if people understanding what's happening here. Find the value of 5 to the power of 2 by 3. Simplify x to the power of 4 by 6. Y to the power of 2 by negative 4. So this is the first of the last one we're doing. And 2 to the power of 4 by a half. To the power of a half. So people saying the first one is 5 to the power of 6, which is good, that's correct, which is an actual number that you can actually write out. So you can actually put 5 to the power of 6 in your calculator and work out that number. 5 to the power of 6. You could work out that number in your calculator, 5 to the power of 6. It could be a stink number, boy. 5 to the power of 6. 15625, a big number. This one is correct as well because they multiply. What about this guy? What about the y? I see no answers for the y. Well done, Danny. Well done. So you're multiplying again, but you need to pay attention to the negative sign. So this is actually y to the negative 8. And if they ask you to go on up one step further, this means this is 1 over y to the positive 8. Remember, this is like two laws coming into play here. So that's a strange one. Strange one. Some strange lands we in here, people. Some strange lands. What about number 4? 4 is 4. Yeah, the answer for 4 is 4. That's true, the big. So why is it 4 though? You get 4 to be 8, which is not correct. Sima, that's another way for number. You can write number 4. 2 to the power of 2 is 4 as well. So the outside like this, it means multiply. Now, if I have the fraction, I could say the root of that, but let's not go into that yet. Let's multiply first and see if we'll get something to happen here. This is actually 2 to the power of 4 multiplied by a half. 4 multiplied by a half is 2. You can work it out on your calculator if you're getting problems. Visualize that. A half of 4 is 2. So this is actually 2 to the power of 2, which is what the answer that people have there. Or just like how I had 5 to the power of 6 and I worked it out, 2 to the power of 2, I can actually work out that and get 4, which is another answer that people have there, right? So 2 to the power of 2 is 4. So that's the first rule. Let's get some more questions in now. Ezra, welcome. A lot of work has been covered. So somebody say my calculator says so. That's not bad. 3, 4. So Ezra, some of this, if you're not accustomed to this, some of this will look like Greek to you. This is why missing maths class is the worst, and this is once again why the online is so good. Because you miss a maths class. I tell my students in school, you miss a maths class and you come in the next day and everything just looking like, what the heck is going on here, right? Missing a maths class is not good. Yeah, so we investigate in the final the law. 64 to the power of a half, what is that? How about 49 to the power of a half? How about 32 to the power of a fifth? Hope that will count. How about 27 to the power of a third? Tell me what these ones are, guys. So number 1 is 8. Well done, Danny. Yes, sir. It will save, right? So if it doesn't come up one time, it takes a little while and then it will come back. The link is always in the group, and I'm going to make the list of all the videos on the online classroom, so you all could always go in the classroom and click which one you want to see and vibes yourself during the holidays and things. Maybe if you want to go to sleep with the sound of my voice talking to you like this. 64 to the power of a half is 8. Alright, and we got that answer because that's actually the root. Sorry for yawning. The root of 64, which is actually 8. Remember, this 2 comes there, right? So square root. This is actually going to be the square root of 49, which is 7. No, not all the time it will work out to nice, neat, beautiful numbers like this. I just making it. So this is the fifth root. The fifth root of 32. So what is that? So I see Charisma have the answer there. But what you need to do on your calculator is look for the square root, and next to the square root would have it. So you'll either press shift or one of those knobs. Or if you're looking at the Y, somewhere around there on the Casio, it's by the hex button. So you just press shift, bam, and they will actually draw something like this and leave a box here in the Casio and leave something for you to write on. Oh, I forget to put the link for the guy with the Casio. But by the way, you could just search on my channel and you'll be able to get it. Just search Casio Cohen Springer and you'll get the link for the Casio for those who live in Trinidad. Or you could order it online. So you put in the 5, then you go down and you put in the 32 to get this very powerful calculator, and you get your answer to be 2. And number 4 is going to actually be the cube root of 27. So this one they actually call it the fifth root. So it was 4 they say the fourth root, fifth root, sixth root. But 3 they actually say cube root, and with 2 they say square root. Cube root of 27 is 3. Because 3 by 3 by 3 is 27. Alright people, some wise in the chat if you understand that totally. We only have 40 more minutes, but that's enough time to dip we two into consumer arithmetic, which is what I ideally wanted to do today. I didn't want to not do any piece of consumer arithmetic. I want to get a little touch of the consumer arithmetic. So let's get our toes wet. Consumer arithmetic. So this is going to take us about 2 or 3 weeks to cover all of this. Some massive topic, consumer arithmetic. Maybe I can spend some time explaining the topic, taking away some more time from it. Now I didn't prepare for this, like list out all the topics in my mind and thing, but as I say, I kind of know everything in maths at the top of my head. So consumer arithmetic, we have a lot. You have the taxes, you have your profit and loss, you have your compound interest and simple interest, you have cost price, selling price, mark price, you have hire purchase, you have bills, and by bills you mean your water bill, electric bill, and shopping bill. So water, electric, and shopping bills. The easiest consumer arithmetic question is the shopping bill question, because the hardest thing in that might be VAT. So you have bills in consumer arithmetic. You have exchange rate. This is normally a hard question for some people. You have salary. You have commission. Anything to do with money in maths. Anything to do with money. It's just get consumer arithmetic. It's just get real tedious with a lot of stuff. So we're going to do every single thing on the syllabus in consumer arithmetic. So have no fear. Consumer arithmetic is, most people, even though you're not so hot in the maths, most people understand consumer arithmetic, but it's a given. But what will happen, as I said, without revision, you'll just forget everything and you will fail. you will fail if you don't revise, right? So when we understand each topic in consumer arithmetic, because it's so vast, you need to constantly revise and make sure you have it refreshed, and especially before the exam, you run it through to make sure you're ready for consumer arithmetic. So let's take a quick look at the basics in consumer arithmetic, which is what we wanted to do today. That's these topics: profit and loss, tax, discount, cost price, selling price, and mark price. So let's start off with the cost price, selling price, and marked price. Alright, so this is a jersey. Believe it or not, this is a V-neck polo, right? So that's a V-neck polo all there. if the tag on it has $50, right? Anything you see marked there, anything you see marked there is the marked price. So this what you're seeing here, that is your marked price. Because that's the price that marked down. So that's the marked price. Now the marked price is usually the selling price. But there's sometimes I can real draw, I know. there's sometimes the sarcasm is strong with this group, boy. Or they want me to waste some time fine tuning this diagram, or like say we here whole night during I should not put them lines in the back, like are killing it. So the marked price is usually the selling price. But there are some cases where the selling price is not the marked price. Could you think of a case where the selling price will not be the marked price? When will the selling price not be the marked price? So the marked price is usually the selling price. The selling price is how much you pay. How much you pay for the shirt, how much you pay for the polo, for Ralph Lauren, how much you pay, right? Discount is a situation where that could happen. So if they have a $50 there, and you go on up in Francis Fashion and you put the shirt down there, and bargaining and sales, that's great. And you whip out your card and you see you have a black card, all of a sudden the selling price is 25% less for you. And I have my Francis Fashion black card too, but I didn't bring it. Right? So you all of a sudden you're going to pay a quarter of that. You're going to pay $40-something, and that will be your selling price. So the selling price is how much you actually pay at the counter, right? But the marked price is how much they advertise the jersey for. Sometimes they will advertise, they will boost. Sometimes the store so tricky, they will raise this up just to make it look a certain way now. So they will send that up to maybe $80, and then they tell you get a $30 discount. But this time it was really $50 to begin with. So a trick is to raise up the mark price high so that the selling price looks sweet when you get them the discount and psychology now. But so we talk about the mark price, we talk about the selling price. What is the cost price? So the cost price, this is interesting. The cost price is actually, take this as a pinch of salt there, because it can sometimes the cost price and selling, it depends on whether you are the retailer or the wholesaler or the customer. What price applies for you, right? So yes, the price they purchase it at. So the cost price would be the price that it costs for the person selling it. You understand? So if they got this jersey for, let me say it's Rattans, and they get the jersey for $10, you could start to figure out a whole sort of thing. Let me say they tell you that you get 10% discount now. 10% discount. Anybody know what 10% of $50 is? It's 5. 10% of 50 is $5. So it means you're gonna pay $45 paid. So we have all the prices here. This is actually the selling price. That's how much they're selling it for, $45. This is the mark price. That's how much they're advertising it for. See, that is correct. That's if you are the store, right? And the cost price was $10. So now you could see that they're making a clean profit of $35 because they buy it for $10 they put it up on the rack and say that it's $50, but you really sell it for $45. So the profit is the difference between your selling price and your cost price, not the mark price. Now you see that little simple explanation that I make there? So many people is messed that up in the exams. I mean, it sound easy, but it just somehow in a question, people will just mess it up. And that's a lot of things in maths. There's a lot of things in maths. So you want to make sure you have that clear in your mind so that when the question comes, you're thinking clearly about that topic. Right? So that's one thing we wanted to talk about. We're not doing the questions on it now because that will just kill off my time. Is that the last of the Mohicans? Oh, yeah, tax and discount. So we mentioned discount, we mentioned profit. Loss will be obviously if they decide if they end up selling the shit for, and no retailer will do that. You normally only make a loss like if you're selling cars or something and you can't get it sell for a certain price. So, or if you're selling goods in the market or something, you can make a loss on plenty different things, right? If you're selling goods in the market and the goods nobody want to buy it and you end up selling it off lower than you buy it for, you make a loss. When your selling price is less than your cost price, you make a loss. You're not getting anything from it. So if this was actually like $9, they'd have made a loss of $1. Or if they didn't sell enough t-shirts, so they end up with a whole set of products on them, the selling price was more, but they didn't sell enough t-shirts, they still make a loss. So it takes some examining the question to see what is really going on. Loss and profits can be written as a percentage. You can write it as a percentage. Now, most of the time, 99.9% of the time, profit and loss percentage is written. Where you living down south or or rain not reach you? Rain just pass and done here. When most of the time when you're working on profit and loss percentage, you have to put it. Let me ask, which one do you put it over, the cost price or the selling price? So like if I had, okay, like this was 35%, 35 St. James, right? So this was $35 was the profit. How are we going to find the profit percent? Are we going to put the 35 over the 10, or are we going to put the 35 over the, how much you sell it for? 45? Which one? This was the cost price. This was the selling price. How do we work out the, and then you have to multiply by 100, right? Multiply by 100. Multiply by 100 to find the percentage. Now we're going to do this in depth. So this is just a little touch. We just dipping the toe into consumer arithmetic here in preparation for next week. So nobody is telling me nothing. Nobody wants to guess. So somebody says CP, meaning cost price. Anybody else? Somebody said 10, which was the CP in this case. So people holding on the CP. Anybody feel a selling price? Seema said cost price. Ricardo said cost price. Sherry, you want to step out and say selling price? Oh gosh, Sherry, you should not step out. You should not step out. You should not step out there. Actually, getting it wrong is part of the thing. I encourage you all, try and get things wrong as much as possible if it means answering as much as possible. In fact, one of my slogans in class, all classes across the board, could be top class, could be not a top class, get it wrong, get it wrong. Students are too afraid to get it wrong, mostly because when you come from a school and you get something wrong and people laugh at you and things, it really affects your psychology. Or when you come in you meet a bad teacher who shame you for getting it wrong or something. So it's not selling price, it's actually cost price. Most of the times profit is, because think about it, it's more meaningful for me to know how much money I'm making based off of how much money I am buying stuff for. So like if I bought something for $100 and I made $10, I don't want to put the $10 over how much money I sell it for. I want to put the $10 over how much money I bought it for. I want to see how much percentage of money I'm making. So to see how much percentage of money you're making, you need to put it over the cost price. This will tell you the accurate percentage in terms of cost price, in terms of how much money you spend to how much money you make. So profit and loss is normally established over the CP, the cost price. One last thing before we dismiss class. What's the last thing, right? Tax. So tax is a form of percentage. Tax is a form of percentage, and once again we'll go in depth with this. Tax is normally at about 15%. So if you have any item and you have to put tax on it, you multiply by 15 over 100. So this takes us to the 2-hour margin. We'll have to call it George here. The time is 8:38. When is the next payment due for class? At the start of next month. So that kind of falls into play nicely because month end, cash in hand, could set up your bills properly. And if you have any payment problems and things, don't ask me in the group directly. Don't ask me. Don't ask me. Ask the class admin, right? So the class admin, she has all the information. She could run through everything and we'll get out the chip. So those who skipped a payment, who late on payments, because there are a few people who late on payment, let's work it out with her. I'm not the kind of person to gangster here, but try and pay on time, right? If you can't pay for whatever reason, you had to miss a month, just talk to her and work out a situation, work out something. Even if you had to pay it in parts, even if you owe me for like about 2 months afterwards or whatever, I know I will pay in the end because we are calling it. Right? So organize. Alright, so later enjoy the class. Oh, and you could remember if you refer someone to the class, you get $100 off your next payment. So once they start the class and pay, you get $100 kickback, right? So that's like a promotion to increase the viewership on the online class here, because I think with what we have, we could actually increase the viewership and everybody could still be taught well. All right, so later people, hold it down. Blessings. Thanks for all who came out and all who answered, and I think we learned a lot. You'll be getting the homework sometime tomorrow, please God, because tomorrow is a holiday. I have a class from 9 tomorrow, so I'll have that in the morning done. So sometime in the afternoon, you should see your homework pumping in towards you. I'll try to give you 2 sets of homework, which will be one simple quiz where I can easily see all the data, and then a lot of homework where I will have to just give you the solutions and you could compare the solutions. So the big chunk of homework will be on indices and ratios. That's where the big chunk of homework is going to be on. Alright people, goodbye. Hold it up. You're welcome.